Good afternoon.
Good
My name
afternoon.
is Ajay Thixotropic, and I'm here to discuss the characteristics of exotropic system and its application. Introduction. Exotropic is defined as the reversible time-dependent reduction in viscosity of a material when subjected to stress, followed by the gradual theory of its origin, structure, and viscosity when the shed is removed. Barnabas, 1997. Unlike simple shear thinning fluid, which responds instantly to shear, reciprocology system inhibits a time lag in both the breaking down and rebuilding of their internal structure. This behavior is often observed in colloidal suspension, gels, and emulsions, where the materials microstructures such as particle network or molecules arrangement is distributed under shear and slowly forms at rest. For example, we have ketchup is a classic exotropical material. It remains thick and gelish like when undisturbed, but flow easily when shaped or squeezed, only to regain its original viscosity over time. The term toxicology originated from the Greek word "taizik", which means touch, and "trapent", which means change, reflecting the touch-induced change in its flow behavior. So let's go to the characteristics of exotropic system. It has various characteristics which include time-dependent shear thinning, reversible structural breakdown and recovery, yield stress, memory effects, sensitivity to shear history, temperature dependence, stability under static condition. Let us explain some of these characteristics. We have time-dependent shear thinning. In this system, it exhibits a decrease in velocity when subjected to constant shear stress or shear rates over time. Unlike simple shear thinning fluid, the viscosity reduces in exotropic system in its instantaneous but occurs gradually due to the breakdown of internal structure. Barnabas, 1997. For example, in paint, this allows smooth application when reduced resistance during brushing. We have the reversible structural breakdown and recovery. In this, the internal structure of the exotropic system often composed of particle network or molecular association breaks down under shear and reform when the shear is being removed. This reversibility distinguish heterotropic from permanent degradation. For instance, when we have ketchup flow easily, but when shaking, it regains its gel-like consistencies after rest. That means when you have a ketchup, if you shake it, it will flow easily, but immediately you drop it, it will go back to its original consistency. Then we have the yield stress. In this, the yield stress process a minimum stress required to initiate a flow. Below this stress, the material behaves like a solid, and above it, it behaves like a liquid. This is a criteria in application of toothpaste. I'm sure everybody has toothpaste at home. When you press your toothpaste, when you are holding the toothpaste, it's like a solid. When you are holding the toothpaste like this, it's like a solid, but when you open, When you open and press it out, it comes out like a fluid. That is what this heat stress is talking about. Then we have the memory effect. For the memory effect, it retain a memory of their shared rate history, meaning their particle depend on the prior shear exposure. For example, when it is subjected to high shear, it may take longer to recover its viscosity if the previous sheared is extensively. We have another type, which is another characteristics, which is temperature dependence. Temperature influence the behavior of tropical system by affecting the kinetics of structural breakdown and recovery. Higher temperature typically accelerates recovery but may reduce viscosity, altering tropical properties. This is relevant in absorption production when temperature is controlled in critical condition. We have the concentration and composition dependence. The degree of the tropic depends on the concentration and the type of the consistency of the constituents, such as the particles, polymers or surfactants. Higher concentration often aids tropicals by strengthening the network. For example, a clay suspension shows increased tropicity with higher solid content. We have stability under static condition. In this, tropic system remains stable and resets flows under static condition due to their gel-like structure. This prevents sedimentation in suspensions like paint and ensures long shelf life. We have factors influencing tropical behaviors. We have material composition. The chemical and physical composition of a material affects its tropical behavior. We have which includes the following: the particles, their concentration, and the medium in which they are dispersed. For their particle types and shapes, this is the nature of the particles, e.g. maybe it comes in a clay, it comes in silicon or polymers. And for their shapes, maybe it is round like plates or spherical. They influence the interpretation, they influence the interaction. For instance, a plate-like particles such as those in a plate-like particles such as those in a clay suspension exhibit prolonged troposicity due to their ability to form house of card structure under static conditions. We have their dispersed medium. The viscosity, polarity, and chemical nature of the liquid medium affects the particle disperse and interaction. Polar solvents such as water promote stronger electrostatic interaction in suspension, enhancing heterotropic compared to non-polar solvents. We have for under the factors that influence the behavior of heterotropic system, we have interparticle interaction. Under this arise from a reversible breakdown and reformation of internal molecular structure under stress. This strength and type of interparticle interaction are determined by certain characteristics, forces, electrostatic interaction, hydrogen bond and steric effects. We have environmental condition. Environmental condition also affects the exotropic system. In this, we have temperature, we have the pH, we have the and we have shear history. Under shear history and process condition. This mechanism of shear history involves the history of a material, including the magnitude and duration of the applied shear. It influences the tropical behavior, such as the shear rate and duration, such as the time it takes to rest, processing techniques, We have other factors too, like modifying additives. Under that we have surfactants, we have polymers, the industrial application of rheology systems. It is used in painting, heterotop paints such as those containing formed silicone or clay additive remain liquid during brushing or spraying, but quickly regain viscosity to prevent slagging or dripping on a vertical surface. This ensure uniform coverage and enhance aesthetics and protective quality. For example, in architectural coating using heterotopic agents to improve shelf stability and ease application, reducing waste and improving finish quality. They are also used in construction material. In construction material, heterotopic system are employed in materials and grounds. Self compacting concentration with heterotopic additives flow easily into complex molds under vibration but remain stable to prevent segregation. The heterotopic rods used in soil stabilization and turning flows under pumping pressure but jelly rapidly to form stable barriers, enhancing structural integrity. It is also used in food industries. Heterotropic enhance texture stability in foods like sauces, jams, dietary items, ketchups, and so on and so forth. In ketchups, it flows under shakes but or squeeze. When you shake it or squeeze it, it flows but regains viscosity immediately it is being added to surface with food. Food grade thickeners such as gums impact the tropical behaviour, enhancing easy pouring while maintaining product consis ten cy. It is also used for pharmaceuticals. It is used for suspension